In this video, we'll be looking at the chemistry of Group 1 and Group 2 metals. So, both Group 1 and Group 2 metals are in the S block of elements. Hydrogen's up here on its own. There's a D block here and the P block and stuff, and the F block down here. But yeah, so Group 1 and Group 2 are in the S block. This makes them quite reactive actually, and some of the things they can react with is acid. The metals can react with acid, and another thing they can react with is actually water. So let's look at a couple of reactions. So one reaction in Group 1, for example, sodium metal. So sodium metal with water goes to sodium hydroxide. Oh, sorry about that. Sodium hydroxide anyway. Okay. That's aqueous. You may as well include your state symbols. Plus hydrogen gas. Okay. That's not balanced though, so there's, you want 2 Na because you want 2 waters here, and then there's, alright, so that's good. And Group 2, barium. Okay. This is the same. Barium is metal and it's solid with some liquid water. Goes to barium hydroxide. Barium forms a 2+ ion, so there needs 2 hydroxide ions to combine with it in order to be a neutral compound, with more hydrogen gas. And this is barium hydroxide is actually aqueous. And now let's just balance this. We need 2 hydrogens, 2 waters, sorry, and I think that's, yeah, okay. So let's go on to the reactions. Okay, so I'm going to show off the reaction of sodium with water. Hopefully I can get it to focus. Sodium metal. There's water here. Always wear, always make sure you're using protection. Take precautions, guys. So let's do this reaction. You can see the sodium there to the left, fizzing effervescence. And there is the reaction. It's stopped now. No more effervescence. That's how you know it's done. In this part of the video, I'll be reacting barium with water. Only a small piece here, small pieces, because barium is much more difficult to cut than sodium. So let's get to the reaction. There is effervescence occurring, so that's bubbling. You can see the bubbles there. Even with tiny pieces of barium, still manages for effervescence to occur. Great. I just dipped it into the water, and the piece of barium just slightly reacted there. Hence the bubbles. So let's assume that we use 5 grams of each metal in the reaction for water, and what we want to find out is how much gas has been liberated from this reaction. So let's do it. So the N of Na equals 5 grams over 23.0, which equals 0.217 mole. Right. So the N of H2 is actually half of that, because there's a 2-to-1 ratio, and that equals 0.108, well, actually 0.109 moles. Alright, and we can work out the volume of gas emitted by saying the molar gas constant times by the n, or the number of moles actually in this. So 2.61 decimeters cubed of gas would be released in the first reaction if 5 grams was put into water. Let's work it out again for the second reaction. Okay, so in this case 5 over 137.3, much heavier this one, so that equals 0.0364 moles. Alright, N of H2 1-to-1 this time, which also equals 0.0364, and the vol, or the volume, equals this times by 24, which is 0.874 decimeters cubed. So as we can see here, the reaction with sodium for the same amount of mass, or for smaller amounts of mass, well, small amounts of molar mass with the same mass, and much more gas is released. So almost 4 times, is that 4 times the gas? So yeah, around no, actually it's around 3 times. I just wanted to check that out. So yeah, around 3 times as much gas is released, and 2.61 decimeters cubed is 2.6 litres as well, so that's quite a hefty amount of gas being released.